In this videotape, I'm going to be giving you a general basic introduction to the TI-83 graphics calculator. I assume that you each have one of these in front of you and you have batteries in it. Okay? The batteries are housed in the rear here. You can flip this open with your finger, check to see if they have batteries. If you don't have a calculator with batteries, get that before we start. Turn off the tape and get a calculator. By just putting in numbers, for example, 45 plus 2, and then I hit the enter key and I get 47. Just using the primary functions of the keys, I hit the 4 and the 5 and then the plus button and the 2, and for equals, for the sum, I hit enter, which is in the lower right hand corner of the calculator, and it says 47. Then if I want that answer, take away 4. I just have to write minus 4, and that gives me 47 minus 4. I don't have to write 47. If I'm doing a calculation and I want the previous answer and then I want to subtract something from it, I just have to go minus 4. It'll say the previous answer minus 4 and give me that. Now if I want 57 times 2 and I hit enter, I get 114. The multiplication on the screen appears as an asterisk. On your calculator itself, let's go down here, you have plus, minus, times, multiplication and division, addition, subtraction, multiplication, and division keys. When I hit the times key for multiplication, the asterisk appears. Okay, so I hit, in other words, for example, 57 times 2, and then the enter button, and I got that. Let's go back up. And of course, I can have division. If I take that answer and I divide it by 2, and I hit enter, I'm back at 57. Now, if you do not like the contrast, you can change it. You can make what's printed on the screen darker or lighter. If we go back down here, if I hit the second button and release it, if I hit then the cursor point, the arrow pointing upwards, it increases the darkness. And if I hit the second button, release it, and I press the arrow going down, it decreases the darkness. Let's try that. I'm going to hit the second and the arrow going up. Let's see what happens to the screen. Let's go up to the screen. Second and the arrow going up, and it's getting darker and darker until it just goes black on me. Then if I hit the second and the arrow going down to decrease the darkness, it goes this way until it just fades. Okay, so let's look for something in between. I'll hit the second, then I'm going, that looks about right. Let's see. I'm just trying to get a very satisfactory printout that you can see. Okay. Now, if I want to clear the screen, I hit the clear button, which is over here. And I press the clear button. I go up to the screen, press the clear button, I'm back to that. Now this, because I've just been doing simple numerical calculations, if I had been working on functions, hitting the clear key once would only erase the line that I was working on. Hitting the clear key a second time would then clear the entire home screen. Okay. Now, if you look at your calculator keypad here, you might notice that there are 2 minus signs. This minus sign is for subtraction. So, for example, if I want 8 minus 5 and I hit enter, I'll get, of course, the answer 3. This, put before a number, turns it into a negative number. So the minus sign in the parentheses is for negative numbers. This is for addition, subtraction, multiplication, division. This is for the regular subtraction. Let's look at that. Let's go up to the screen. If I punch in 8 and then the subtraction key and then 5 and hit enter, I will have 8 minus 5 equals 3. Now, if I want the number -5, if I hit the minus sign that's in parentheses and then the 5, let's say then I want to subtract 6 and I hit enter, it's -5 take away +6. It's -5 and -6 gives us -11. Now, notice the difference between the two minus signs. The one indicating a negative number is a little higher and a little smaller than the one that indicates subtraction. So the symbol before the 5, that indicates it's the number -5. Between the 5 and the 6, we have the regular subtraction symbol. Okay. If you punch in the wrong one while you are entering a function, you may get an error message, which is flashing at the minus sign. You probably have used the wrong minus sign in that case. Okay. Now, if I put in 1 divided by 3, the number 1/3, and I hit enter, it gives me a decimal equivalent of the number 1/3. Gives it to me with what? 1, 2, 3, 4, 5, 6, 7, 8, 9, looks like 10 decimal places. Now, if the answer to a problem is a decimal and I want the equivalent answer as a fraction, I can hit the key that says math. On the calculator, there's a key that says math. This will give me a menu. Now, when I hit this, I'm going to have a menu of choices on the math menu. I'm going to be able to go up and down, scroll up and down by using these two arrows. This to send my cursor up, this to send my cursor down. So let me hit the math key. Let's go up to the top. I'll hit the math key. And the first option is fraction. The cursor is already on that. If I scroll down, the cursor moves. But where it was originally is on 1. If I hit the enter key, fraction, it says, take the answer that I just had, the 0.3 repeating, and give it to me as a fraction. If I hit enter again, it says, oh, the answer is 1/3. On the other hand, if I go and I hit the math key, and I scroll down to 2, or I hit 2, I can scroll down to 2 and hit enter, or just hit the number 2. And I say, the answer I just had, that 1/3, I'd like it as a decimal instead. If I hit enter again, it goes back to decimal. For example, if I punch in 0.25, okay, I've worked out a problem. I have 0.25. If I hit the math key and then fraction and enter, it tells me that the answer, the equivalent fraction, is 1/4. This is convenient if you're working out a problem, your answer doesn't quite look like the one in the back of the book. You may be able to change from fractions to decimals using the math key. Now, let me clear the screen. Now, suppose I clear the screen and I say, gee, I really wish I hadn't cleared the screen. I had something on there that was important. If we look down here, you see the enter button. In yellow, above the enter button, is something that says entry. If I hit second and the enter button, that's entry. That means the last thing that I entered into the calculator. So if I would like to recall something that I have erased, you've cleared something, you say, gee, I wish I hadn't done that. If I hit the second button and then the enter key, that'll give me entry. Let me try that. I hit second and enter, and it goes back to where I was before. It's the last thing that I had entered into the calculator. If I want the answer that came with that, then I have to hit the enter button, and then it'll tell me that it was 1/4. So you can recall the last thing you wrote in the calculator. If you then want to rework the calculation, you can hit the enter key, and that will do it for you. Okay, by the way, if you want to shut the calculator off, okay, Off is in yellow above the on key. So you hit the on key to turn it on, you hit second and the on key to turn it off. So I'm going to do that. I'm going to hit second and the on key. Let's go up to the screen. That's turned off the calculator. Now if I turn the calculator back on, it generally preserves whatever was on there right before I shut it off. If I want to clear it, I can. And I'll hit the clear key. All right, so far, calculator has just been working the way a regular calculator works, nothing special. We want to start looking at it as a graphing calculator. If we hit the y equals button, okay, we will be able to enter a function in that we wish to graph. So I'm going to hit the y equals button, and I happen to have a function in there, so I'm going to clear it, and I'll be able to write whatever I want. Okay. Now for y equals, let's say I want to graph y equals 8 minus x squared. So I'm going to, let's go back down here for a second, I'll show you what we're going to hit. I hit the y equals key that has y equals flashing now. I'm going to hit 8 minus, now I need x squared. There are two ways to enter x squared. One way is to enter the variable xt, this button here, this will enter x. Now, you can then hit squared, which will be x squared, or that only works for x squared. If you wanted 1 minus x to the fourth, then you would hit 1 or 8 minus x, 8 minus x. This is the symbol for raising to a power, this sort of upside down V. You have addition, subtraction, multiplication, division, and raising to powers. This symbol, if I write x and this symbol and then 4, that would be x to the fourth power. Okay, so let's punch in. I'm going to hit 8 minus x, this is the x key, and then I'm going to hit the squared. So 8 minus x and squared, and I should have y equals 8 minus x squared up there. Now, I want to graph this. The calculator will graph it for me, but you have to pick a viewing window. In other words, you have to tell it what portion of the x and y axes you want to see. Okay, to see the options on that, we hit zoom. If we hit the zoom button, it gives me, right now, I'm interested in options 4, 5, 6, and 7. These are various preset viewing windows that you can use. If I hit 4, well, let's start with 6. 6 is the standard viewing window. If I hit 6, it will immediately graph y equals 8 minus x squared, which of course we recognize as a parabola, on the standard viewing window. If you want to know what the standard viewing window is, if you can't see it from over here, if I hit window, this will tell me what my current window is. Next to zoom, where I picked the window, I picked standard window, the 6th option. If I hit just window, if I press this button, window, I will do that. Let's go up to the screen. I'm going to hit window. It'll tell me the window that I'm currently in. The x values are running from minus 10 to 10 with increments of 1. And the y values are running from minus 10 to 10 in increments of 1. If I hit the graph key, which is over here to the right, we had window, we had zoom, and graph here. In a few moments I'm going to look at this trace key, but right now this is the graph key. I'm hitting graph. It shows me the graph of y equals 8 minus x squared from minus 10 to 10 on the x-axis, from minus 10 to 10 on the y-axis. Each one of those little marks indicates 1 unit. Okay, now, I had just shown you the trace button. I'm going to press the trace button now, and it's telling me that right now, it gives me a flashing mark, and at the point is x equals 0, y equals 8. At the bottom of the bottom of your graph, it shows you that we're at the point x equals 0, y equals 8, and it tells me that the function is y equals 8 minus x squared. It says y1 because there are various, gives you various options. You can program in various functions, and then you can, by calling up y1 or y2 or y3, get the one that you want. You don't have to erase them each time. So here we have y equals 8 minus x squared is the function being graphed, and the cursor right now is there. Now, let's go down here and look at the chart again. I hit the trace button, and it's flashing that I'm at 0, 8. By using the arrows to the left and the right, I am going to be able to move my cursor and generate various points on the calculator. So let's go back to the screen. And I hit the trace button. Now I'm hitting the arrow to the right. So x equals 0, y equals 8. The next point it gives me is x equals, say, 0.213 something, y equals 7.955 approximately. We go again, 0.426, comma, 7.819 approximately, and we keep moving, and it's generating various points on the calculator. Now you may say these are fairly strange x coordinates. How in the world is the calculator deciding to, what is it doing? How is it giving me these? Most people, when they make a graph, x is going up either by a unit or a half, a 0.5 or 0.1. And here we seem to be making, we're making increments, but they're fairly strange. But we go back up, we're at 0, 8. We go to the left, minus 0.213. minus 0.426 for the x coordinate. Okay, they seem to be making increments, if we just look at the x coordinates, from minus 0.213 to 0 to 0.213. If you have 0.213 again, 0.426, we seem to be incrementing by 0.213. Now, how in the world does that number come up, and what can we do about it? Okay. Let's go over here to the blackboard and understand what the calculator is doing. It's going to draw the pictures on an x and a y axis on our rectangular coordinate system. And basically, it's pretending that it has a piece of graph paper. And it's a very interesting piece of graph paper. There are 94 boxes moving from left to right, and 62 boxes moving up and down. And it's going to graph your picture on this graph paper, which has 94 boxes left and right, and 62 boxes up and down. Now, we had used the standard window on the calculator, which has x from minus 10 to 10 and y from minus 10 to 10. So we want to cover a distance from minus 10 to 10, a distance of 20 units. We have 94 boxes. So each box, each time I hit the trace button, it moves it like one box over. Each box is going to move the cursor 20/94 of the way. Now 20/94 is approximately 0.213. It's the 0.2127 thing that we saw before. In other words, it's covering a distance from minus 10 to 10, a distance of 20 units in 94 boxes. So each time you hit the cursor, it's moving at 0.213 of the way. Now you may say this is not a terribly convenient increment. Okay, you do get you get a decent picture, but you might want to change that. You'd say, well, look, is there a way to change this so that I'm going, say, up 0.1 each time instead of 0.213? There is another window that the calculator offers us, which is the decimal window. In the decimal viewing window, x goes from minus 4.7 to 4.7, and y goes from minus 3.1 to 3.1. Now, if I had just let you use the decimal window, okay, you might say, where in the world do these numbers come from? But now we begin to understand. We're going from minus 4.7 to 4.7, a total distance of 9.4 units. And the calculator is going to do that in the same 94 boxes. Therefore, each time we hit the cursor, we're going to be going up by 0.1 instead of 0.213. Similarly, we're covering a distance of 6.2 units in the 62 boxes that we have going up and down. Now, understanding this, let's look now at the picture that we would get using the decimal window. Okay, now I had mentioned that we are right now using the window button, the standard window. Okay, if we hit, if I press window, remember the keys that I'm going to be mentioning are window, zoom, trace, and graph. Okay, they're all up here. After you hit trace, to move the cursor left and right, you use these arrows. Let's go up to the top now and see what we have. This was, if I hit window right now, I see that the window I've been graphing in is minus 10 to 10 for x, minus 10 to 10 for y. If I hit the graph button and I hit trace, and if I bring my cursor to the left, back to the 0, 8. If you go one to the left, look at the x-coordinate, minus 0.213. Again, you hit it to the left, minus 0.426. To the right, 0.213, 0.426. The x's are incrementing by 0.213, which I'd mentioned is 20/94. Okay, now let's say I want to use the other window. I'm going to hit the zoom button, and I'm going to choose, instead of the window choice 6, which is the standard, I'm going to use, the two favorite ones that we use usually are the 6 and the 4. 7 is particularly good if you're graphing trig functions, but right now we're not doing that. So 6 is the standard window for minus 10 to 10, and 4 is the decimal window. If I hit 4, now you can either scroll down to 4 and hit enter, or you can leave it where it is and just punch the number 4 in. In either case, it graphs using, if we hit the window now, it switched my window from minus 4.7 to 4.7 for x, minus 3.1 to 3.1 for y. If I hit the graph button, I'm seeing y equals 8 minus x squared, but only in that viewing window. Now you say, well, that's not fabulous because I'm cutting off a lot of the, I'm cutting off the turning point of the parabola and so on. You might want to make an alteration here in the y values. If I hit window again, okay, if minus 4.7 to 4.7, that seems to be working okay. It's the y coordinates that are not good. I scroll down here, I can alter this, okay? Let's triple the y values here. In other words, instead of 3.1, I'm moving the cursor, I'm going to punch in right over that, I'm editing this, 9.3. And for the biggest one, let's triple that, 9.3. So that was 3.1 times 3. Now let me hit the graph button. And now I see the y equals 8 minus x squared. I have a different scale on the x and the y axes, but at least I'm seeing the parabola. If I hit the trace button, it's at 0, 8. Now if I move to the right, the next value is 0.1, 7.99. The x value is 0.1. Again, 0.2, 0.3, 0.4. I'm managing to increment by going up by 1/10 each time. Okay? Now, that's just an option. That's if you want to be able to control the x-coordinates, you can use the decimal window. Let's say I understand that and I'm willing to live with the other window. I'll hit zoom. Let's go back to the standard window. I hit 6 and it switches it back minus 10 to 10. You might prefer this because you have the same scale for the x and the y axes. Now let's say we're interested in where the curve y equals 8 minus x squared crosses the x-axis. In other words, we have y equals 8 minus x squared. It's a parabola that looks like this. 0, 8 is the turning point. And we're interested in where it crosses the x-axis, the x-intercept here. Okay? The x-intercept is found by setting y equal to 0, so what we're looking for is setting y equal to 0, y equal to 0, or 8 minus x squared equals 0. X squared is 8, x is plus or minus the square root of 8. So this must be plus the square root of 8, this is minus the square root of 8. Okay. Now, there are various ways to locate the x-coordinate. This is a particularly simple problem. Obviously, we know what the square root of 8 is. We can punch in the square root of 8 and find out the answer, but there'll be other times when it's not that obvious, and I want to show you how the calculator can find you that point. Okay, let's hit the trace button, and let's move the cursor to the right, getting close to the one that we're trying to find. In other words, 2.7 something, 0.3 something, I move it again, 2.9 something minus 0.8 something. In other words, go back. Obviously, the x-coordinate of that point is someplace between the 2.7 and the 2.9, because the y value is going from positive to negative, and therefore someplace in between is where it's crossing the axis when it's 0. Okay. I would like to get a better, more accurate picture of what's going on here. So what I can do is hit the zoom button. And you see where it says zoom in. I can go down to 2 for zoom in. I want to zoom in the picture here and hit enter once and hit enter again. And it's going to blow up. What you're seeing here is this portion of the x. What we're seeing is this portion of the x-axis and the parabola. Whereas it's going to look almost like two intersecting straight lines. But the horizontal line, that's the x-axis. And this vertical thing that we're seeing is really just a blown up portion. In other words, it is enlarging what I've circled here, this portion of the curve. Okay, let's go back up to the screen. Now, hit trace, and you're over here. Now let's move to the right, and we see we have 2.8, the y value is positive, 2.87, the y value is negative. Let's zoom in again. Hit zoom, scroll down to 2, or hit the number 2, hit enter for that option, and then hit enter again. And now hit the trace key, and we're over here. Go to the right, it's negative, the y value, to the left it's positive. Whereas I now know that the x-coordinate of the point of intersection with the x-axis is 2.8 something. Let's hit the zoom button again. This time, instead of scrolling down to 2 and hitting enter, I'll just punch in 2. But you still have to hit enter again. In other words, either enter twice or 2 and then enter. It's blowing up this portion again. I hit trace, and I'm over here. I'm backing up. Okay. Hit zoom, hit 2, and enter again. Hit trace, go to the right. Here I see 2.828 something. The y value is positive, but very close to 0. I go to the right, and I see 2.829. The y value is negative. Let's zoom in again. Hit zoom, hit 2, or scroll down to 2 and hit enter. Just punch in 2 and then hit enter again. And the trace key is there. Let's hit trace, move to the left. And I now know that the x-coordinate is someplace between 2.828, 2912, where the y value is negative, and 2.828499, where the y value, first the y value was positive, now the y value is negative, both cases close to 0. And you can keep repeating this. You can hit zoom, 2, enter, hit trace, go to the left, and keep narrowing down the location of the x-coordinate. So we know it's approximately 2.828, which is not a surprise. If I, let's look down here. If I want to go back to the home page, I'm going to hit second and quit to get rid of this picture. And I'm going to hit second and this key to get the square root, and I'm going to put 8 in there. And then I'm going to close the parentheses to see what the square root of 8 is. This gave me about 2.828 something, and I'm hitting second. I'll hit second and quit. I'm on the home page. Second to get the square root. Punch in 8 and close the parentheses. Hit enter. 2.8284. So that's the actual answer. Now this has not been a very fast method. I mean, we're zooming in over and over again. It doesn't require a lot of work, but it hasn't been very fast. There is another way of finding out the answer here. There are actually many ways the calculator can do this. I want to show you another method in a moment. Now I'd like to show you another way that we could find where this curve y equals 8 minus x squared crosses the x-axis. Okay, there are various options on the calculator. One method of doing this is to use a function that's stored in the calculator called solve. Now, to get solve, I'm going to hit second and the 0 key to get catalog. That's a catalog of functions in the calculator, an alphabetical listing of all the functions that are stored in the calculator. Now, it's like a dictionary, and I'm going to be starting with A, except the button I want is solve starts with S. So, you see the green letters. I'm going to hit the key that says LN on it. I don't have to use the alpha key. I'm just going to hit the key that says LN. That's going to take me to the S portion of the dictionary. And when I hit the S portion of the dictionary, I'm going to scroll down using this arrow till I get to solve. When I get to solve, I'm going to hit enter to enter the solve button in. Now, let's try that. I'm going to hit second and catalog. I'm pushing second and catalog. Let's go up to the screen. I'm hitting second and catalog. This is the beginning of the dictionary. Okay, as I said, you're starting with the A's. I don't want to go through A, B, C, D, and so on, so I'm going to hit the S key, that LN key, to get me to the S portion, and I'm scrolling down till I get to SOLVE. There I have it. Solve, and I'm going to hit enter. By the way, if you have a TI-82 instead of a TI-83, solve on the TI-82 was an option on the math menu. It was option 0. Those of you who have the TI-83, there are many more functions in the calculator, and they're using this catalog to store them. Now, look at what we have here. Solve. You're being offered solve with a left parentheses. You're going to put in the function that you want to set equal to 0, the equation that you want to set equal to 0. And it's going to be the y1, which was the 8 minus x squared. Then you're going to tell it, then you're going to put a comma in, and the comma is located right above the 7 button. 7, and you see the comma. Parentheses are here, over the 8 and the 9. Comma, left parentheses, right parentheses. Okay. So, comma, x, comma, a guess at what you think the solution is. For example, we know, for example, this particular equation, when we set y1, which is 8 minus x squared equal to 0, there are two solutions, namely plus or minus the square root of 8. Okay? If we guess around 2, we'd have to go back for, if you wanted to look for a guess, in other words, let's go back temporarily. I'm going to hit the y equals key. You have the y equals 8 minus x squared. Now, if I press window now, okay, the window has been altered because when you zoom in, you mess up the window. In other words, remember the window is what you're viewing on the calculator. Every time we press zoom, we looked at a blown up version of a smaller portion of the graph. So we can see that the window has been changed. If I hit zoom and let's see, 6 for standard. If I graph this, I have an and I hit the trace button and I go to the right, I'm saying, in other words, I know somewhere between 2 and 3, so I'm just picking my guess as 2. So I'm going to hit second and quit to make this disappear and to go back to the home screen. Second, and then the mode button to get quit, and I'm back where I was. Now, so for my guess, what I want to enter is y1, x, and my guess, let's say 2. And then I'm going to hit enter. Now let's punch this in. Now how do I punch in y1? I'm going to hit the variable key, VARS, variables. I'm going to punch that in. It's going to give me a choice of x variables or y variables. I'm going to scroll over to y variables and enter in y1. In other words, this function has been entered into my calculator as y1. So I hit variables. You see it's on variables. Those are the x variables. I want y variables. I hit the arrow to the cursor to the right to get y variables. And then I hit enter to get the function. And now if I wanted y2 or y3, I would scroll down. But since the one I want is y1, I'm going to hit enter. And that puts y1 right in there for me. So I hit variables, scrolled over to y variables, and hit enter to get function, and then enter to get y1, the first function that I wanted. Now I need the comma. So the comma is right above the 7 key, and I hit that. And then I write x. That's from the xt, theta, etc. key. So I just put, hit the x. That tells me I want to solve the equation y1 equals to 0. And the variable is x. Hit the comma again and punch in your guess 2. Close parentheses, and we hit enter. And it gives you immediately. You don't have to keep zooming in. It looks a little complicated now, but you will very quickly get the hang of it. It gives you, of course, the same answer as the square root of 8. This is a very painless way to solve an equation. By the way, if you wanted to, instead of doing y1, you could have the option, if I hit the second and the catalog and the S, and I scroll down to solve, and I hit the enter. Instead of writing y1, I do have the option of actually punching in 8 minus x squared. That's the function I want to set equal to 0. Equation, comma, x is the variable, comma, 2 is the guess, and I hit enter, and it gives me the right answer. Now, suppose you wanted the other solution. Of course, in this particular problem, we know the other solution is negative square root of 8. But sometimes you have, for example, you could have a curve that crosses the x-axis at various spots, and you're looking to find, you could have a curve that crosses the x-axis at various spots. You're looking to locate these 3 x-intercepts. And you know approximately that maybe this is about -2, this is about 0, this is about 3 or something. So you just want to change the guess. I got this one, I want to look for that one. Now instead of having to, let's go back to the screen. Instead of having to re-punch in catalog to get the solve key up again, I can write second and enter. That gives me the last thing that I'd entered into the calculator. And then I can scroll over and edit this. So instead of 2, I can put in a minus 2. Now, you can just write right over this, minus 2 in close parentheses, or there is a key here on the calculator. You have DEL, which deletes, and INS, which inserts. So if I hit second and the DEL, that'll insert whatever I want to put in. So if I'm flashing on the 2 up at the top, and I hit second, insert, and I put the minus sign with parentheses, it puts in the minus 2. If I scroll over and I hit enter, it's going to give me the negative square root of 8 answer. But of course, I mean, we don't need it really for this because we know plus or minus the square root of 8, but there are other times that you might just want to edit something in the equation, in the formula you're using. You can just hit second and enter and get the last thing you entered into the calculator without actually having to get the solve button again. Okay, the next thing I want to do with you is to show you how to graph two equations at one time. Let's hit the y equals button. I'm going to clear that one. Now I want to graph y equals x squared minus 8. So I'm going to hit x, then the squared, minus 8. I want to solve that simultaneously. Now hit enter. And now I want to solve that with y equals x minus 2. Hit the x minus 2. Okay? Now let's look at the window that we're using. Let's change, well, let's graph it this way. It graphs y equals x squared minus 8 and y equals x minus 2. Now, if you want to find points of intersection, you can hit the trace key, okay, and right now the trace key is tracing the y equals x squared minus 8 curve as we go around. If you wanted to trace the other key, the other curve, okay, it's on this one. You hit, come down here, look for a second at the calculator. It switches between the two functions that it's graphing simultaneously if you hit one arrow or the other arrow. It'll go from y1 to y2 and back and forth. So let's see. If I hit the lower arrow, the other cursor, it's now graphing, it's now tracing along. Okay, if I hit that, it's tracing on the y equals x minus 2 curve. If I hit the other curve, the arrow, it goes to the other one. Every time you hit it, it switches to the other curve. Now it's on y equals x squared minus 8. Now it's on y equals x minus 2. Okay, so you can move to the right here looking for the points of intersection. Now, we're on one of the keys. We're on the curve y equals x minus 2 arrow. I'm on the other one. Or there seems to be some kind of some intersection in this vicinity. You can choose to blow this up. You can zoom on this repeatedly until you get a better feeling for what the points of intersection are. Another choice is to go to table. Now if we look down over here, hit second and window. That's going to give you the table set button. Second and window. Table set. Now you should have your table set up so that the independent variable is listed for ask and the dependent auto. Or if yours is the other way around, if your calculator looks like this, and this is the one that's lit up. Very often when you purchase it, they look like this. That's going to automatically decide on how it's going to make a table. We want to have some options, so we're going to move the cursor over to ask and hit enter. Now I'm going to, as long as this is ask for independent like that, I'm going to hit the table key, second and graph. That'll hit me the table key. Let's go back up to the top and we have second and table, and it's prepared to tell me what the y coordinates are for both curves as I punch in various values for the x coordinates. So, for example, I can hit minus 4, minus 3, minus 2, minus 1, 0, 1, 2. If I want to then punch in 3, it would erase that. I'm only mentioning that because I noticed from this that if you look at x equals minus 2, the y values on both those curves turned out to be minus 4. That was one of the points of intersection, minus 2, minus 4. And if you look, the y1 and y2 agree on x equals 3. So in other words, the 2 points of intersection are really minus 2, minus 4, and 3, 1. If we go back to graphing, in other words, minus 2, minus 4 is 1 point of intersection, and 3, 1, I believe, was the other point of intersection. There's so much you can do with the calculator. It's not that much time on this tape to teach you that much about it. If you change the window here back to zoom decimal 4, okay, and if you hit the trace key, because of the fact that we're trace, we're not on the curve, it's not in the window yet, we're just, there we see it. It'll actually take us to this. If we switch from one curve to the other, we see that 3, 1 is on both curves. It happened to be a point of intersection that had integer coordinates, but aside from that, zooming in would give us an accurate idea of where the points of intersection occurs. And there are other ways the calculator will give you, will actually solve simultaneously curves. And more about that in the next videotape. That brings us to the end here.